Hello, good day viewers. I welcome you all to this additional mathematics presentation. So in this presentation, I want us to answer this question right here. So the question reads, given that 2x plus 4y is equal to 10 and x plus 5y is equal to 8. So for x and y using the matrix inverse method. So here we are being given two linear equations. We have this one, 2x plus 4y is equal to 10 and x plus 5y is equal to 10. So we are going to solve these systems of linear equations by using the inverse method. So what are we going to do? First step, we are going to write the linear equation that you have been given. So we have 2x plus 4y is equal to 10, and the second one is x plus 5y is equal to 8. So now from here we are going to present them now in matrix form because we are being told to use the matrix inverse method. So what you are going to do is this. We are going to take the coefficient of x and y. Okay, so the coefficient of x here for the first equation it's a 2. So you write a 2. The coefficient of y here on top it's a positive 4. Then the coefficient of this x down here it's a 1. The coefficient of this 5y or this y it's a positive 5. Okay, you enclose them in brackets. Then what variables are we using? We are using x and y. Okay, and then we equate to the constants, which are the answers, which is 10 and what? 8. That is what you are going to do here. So after doing this, what we have written here, we are calling it as the matrix what? Equation. So from this matrix equation now, we are going to take the original matrix, which is this one, which is having 2, 4, 1, and 5. And we are going to give it a name. So you can give it as A equal to, which is 2, 4, 1, and 5. So from here, we are now going to find the inverse of matrix A. So the inverse of matrix A will be found by getting the cofactor of matrix A over the determinant of matrix what? A. Okay, so that is what you are going to do here. So what you need to find here, first thing, find the cofactor of matrix A. So the cofactor of matrix A is found by changing the major diagonal element. So you can see this is our matrix A. Or let me give an example. If your matrix A is having the elements A, B, C, D. So to find the cofactor of this matrix A, you write cofactor of matrix A is equal to. So these major diagonal elements, they will swap. The D will go where A is, the A will go where D is. Then these minor diagonal elements, you change their sign. So this is a positive B, it becomes a negative B. And this is a negative C. Sorry, it's a positive C, becomes a negative C. So this that you have written here is the cofactor of matrix what? A. So we are going to do the same. The original matrix is this one, 2, 4, 1, 5, which is this one right here. So 2 and 5, they will interchange. So the 5 will be on top. Okay. Then to this 4 is a positive 4. We'll change the sign, which will be a negative 4. Again, this one will be a negative 1. And these 2 will go where 5 is. So it will be like this. So this is the cofactor of what? Matrix A. Then after finding the cofactor, you can look in our formula here. We also need to find the determinant of what? Matrix A. So I'm going to say the determinant of matrix A is equal to, so this is the original matrix A. How do we find it? Its determinant, we say the product of the major diagonal elements, which is 2 times 5, minus the product of the minor diagonal elements, which is 1 times 4. That is how we find the determinant of the 2 by 2 matrix. So remember that matrix A is a 2 by 2 matrix. Okay. So you write A, determinant of A is equal to, so we have 10 minus a 4. So 10 minus a 4 will give us a what? A 6. So the determinant of that matrix is a 6. Then from there, we can just substitute in our formula because we have, in this formula you can see it's cofactor of matrix A over determinant of matrix A. So where there is cofactor of matrix A, we'll put this cofactor here, or we can call it the adjoint. Where there is determinant of matrix A, we'll put this determinant, which is a 6. Okay, so we can now substitute. So we are going to say A inverse is equal to, so we can say this 1 over 6, this is the determinant. Then the cofactor that we have a 5, a -4, a -1, and a 2. So this is the inverse of that matrix. So upon finding this inverse of the matrix, what you are going to do is you are going to multiply now on both sides of the matrix equation by this inverse of matrix A. So I hope you are able to recall the matrix equation that we came up with. Let me just take you back. So this is the matrix equation that we had. So on both sides of this matrix equation, we are going to multiply with the inverse of matrix A that we have found. So our answer is going to be written like this. Okay, so this is how we are going to write it. So we are going to start with this one, which is 1 over 6. We are multiplying with the inverse, which is 5, -4, -1, and 2. So we multiply with what we had on the left hand side of the matrix equation, of which we had a 2, a 4, a 1, and a 5. Then we also had the variables, which is x and the y, equal to, so to the left, to the right hand side, we also multiply with the inverse of matrix A, which is 1. Then we have 5, -4, -1, a 2, which will be multiplied with the 10 and the 8, like this. So after writing this, what are we going to do? So what you are going to do now is you multiply these two matrices together. So let me just enclose them in square brackets. So 5 row by column. So 5 times 2, this will give us a what? A 10. Then 10 plus -4 times 1, this will give us a -4. We are done here. Again, row by column. So 5 times 4 will give us a 20. Okay, then plus -4 times 5, this will give us a -20. We can close here. We come to the down here, row by column. So -1 times 2, this will be a -2. Then plus 2 times 1. Okay, 2 times 1, this will be a 2. Again, row by column. -1 times 4, this will be a -4, plus 2 times 5, this is a 10. Okay, so this 1 over 6, you can just write it outside here. You say 1 over 6. Okay, 1 over 6. Then here we write x, y, equal to, then on the right hand side again, we multiply this matrix and this matrix. So row by column. So 5 times 10, this gives us a 50. Then plus -4 times 8, this gives us a -32. Then again down here, row by column, -1 times 10, this gives us -10, plus 2 times 8, this gives us a 16. So this is what you are going to have. Don't forget that you have 1 over 6 outside there. Then after writing this, we can just simplify what we have gotten. We can just simplify. So we are going to write 1 over 6. Okay, we just simplify. 10 plus -4, this will be a 6. 20 plus -20, this will be a 0. -2 plus 2, this will be a 0. -4 plus 10, this will be a 6. Okay, then we write x, y, equal to, so here we write 1 over 6. Then we say 50 plus -32. This will give us 18. -10 plus 16. This will give us a 6. So this is what you get. So now from here, you can multiply with what? With what is outside, which is 1 over 6. So 1 over 6 times this 6, it's a 1. You get a 1. 1 over 6 times 0, it's a 0. 1 over 6 times 0 again, it's a 0. 1 over 6 times this 6, it's a 1. So this is what you get. Then you write x, y. Okay. Then equal to 1 over 6 times 18, 6 into 18, it's a 3. Then 1 over 6 times 6 gives us a 1. This is what you are going to get there. Now, you can see you have 1, 0, 0, 1. This type of the matrix that you have gotten, this is an identity matrix. So, 1, okay? So, we are saying we have gotten 1, 0, 0, 1. This matrix. So, this is what we call identity matrix. So, an identity matrix, it has some properties, okay? Number 1, the determinant of an identity matrix is always a 1. Again, when you multiply any matrix with an identity matrix, you get the same matrix. So, if we multiply this times xy, we'll get xy, okay? So, we know that we'll get the same thing, which is xy. When we multiply with the identity matrix here, is equal to 3, 1. Remember, the question said we should find the value of what? Of x. So here, we can just equate. We just say, therefore, this x is equal to 3. X is equal to 3. And y is equal to 1. Okay, so these are the values of x and y. So thank you so much, everybody. We've come to the end of our short presentation. This has been your presenter, Mr. Mlenga. Bye-bye.